right, what I'd like to do for right now is kind of go over what we've done so far, tell you what I'd like to do for the rest of the week, how I see next week playing out, etc. All right? Now, a couple of you have talked to me individually, but again, if you are struggling in here for whatever reason, if you are struggling in here, you have to let me know. All right, because I've said this before, I'm not clairvoyant, so if you're having problems, I don't know it, and I have had a couple people who have said that they are willing to work with people in here. All right, now we went over Chapter 1, and that was not much in there, to be honest with you. Then we went over Chapter 2, and yesterday we went over Chapter 3. If you were not here yesterday, all right, it was taped and it's out there on the YouTube channel. Okay? Tomorrow, I'd like us to go over and do the written test for Chapter 3. Friday, I'd like us to do the written test for Chapter 4. All right? Hopefully, what you found was Chapter 3, the using GUI objects in the Visual Studio IDE, in a way at least, was a little bit of review from what we'd already done in class. All right, so there wasn't a whole lot of learning in there. It was a lot of hopefully seeing it in action, etc. What I'd like to do today, all right, I'm changing it around a little bit, but when you take your next test, I think your next test isn't going to be until the middle of next week. Now, sometimes, just so you know this, Mr. Corrigan, who's next door, is a super good guy, super good instructor, but he's one of the most regimented people I've ever seen in my life. And what I mean is, if he puts down in there, you're going to have your test on Monday, come hell or high water, you're having your test on Monday. That's how he does it. I'm not saying that's right or wrong. All right? But what I'm trying to tell you is, I think that we should go over this stuff and make sure you've got a really good understanding of it, rather than Monday saying you're taking a test on it. All right? So this is what I would like to do. All right? I'd like to today go over right now Chapter 4. Even though it looks like it, it's not a real long chapter. All right? And it's on what are called, it's on decision-making statements. There are two of them in this language, an if statement and a switch statement. We'll go over both of them. All right? Then tomorrow, I'd like to go over the looping chapter. All right? And then Friday, so tomorrow when you come in, you will take the written test for Chapter 3. Okay? And then we'll go over the looping chapter tomorrow. Friday, you will take the test for Chapter 4, the written test. The rest of the period will be lab. So you'll have a good 3 hours worth of time that you'll be able to just do lab. All right? Then on Monday, I'd like us to take the written test for Chapter 5. Okay? Then what I'd like us to do, just to make sure that everybody is caught up, is to give you the rest of the period Monday as well for lab. All right? Then Tuesday when you come in here, what we'll do is, and this will not be graded or anything else, okay? But Tuesday, I would like to give you what I like to call a practice test. So it's going to be very similar to the type of problem that you'll have to do, but I'll give you a couple hours to work on it, and then we will go over it as a class. Does that make sense? And then Wednesday, so a week from today, you would have your next hands-on test on Chapters 3, 4, and 5. Now that's what the test is on. That doesn't mean there won't be anything from Chapters 1 or 2. All right? But I think if we get there, then after 3 weeks, all right, basically, we're done with the first 5 chapters of the book, and that's not too bad. All right? When we get to these chapters, like for instance, Chapter 6, okay, we'll spend more time on that. It's a little bit more complex. Chapters 7 and 8, we can almost do together because one bleeds right into the other one. All right? In my humble opinion, 9 and 10 are the hardest 2 chapters in the book. All right? So we'll probably do one, then do the other, and then look at an application that brings in both. All right? Chapter 11 It's on exception handling. Don't worry about it for right now. But what I plan on doing then is when we get to this point right here, okay, we're going to go over all 3 of those chapters at the end and then just have one last test. All right. Now, my hope is still that somewhere around the time we break, which is March 12th, that we'll be at this point. If it turns out that, let's say we're here and it's March 12th, then we're there. I don't care. I want to make sure you get this stuff. Understanding this is fundamental for taking the next class, because the next class that you take in the progression here, all right, is AWD1100, and it is a class using a language called ASP.NET. But you know what? It's not really a language. It uses C# for everything you do, but you build web apps with it. All right. Now, you two won't be able to take that class in fall, just so you know, because of the fact you have to take the first 2 classes first. All right. And since you weren't here last semester, you'll have to take that class. All right. So that'll put you behind kind of a little bit. All right. Now, I can ask Charles if there's any way, if you guys are interested. And if you're not, it's okay. But if you're interested, I can ask him if there's any way that he would consider letting you do the class independently, the fall one in summer, so you could catch back on. I don't know what he'll say over that. Okay, I have absolutely no idea. And you'd still have to pay the regular price and everything. All right, I don't get paid for it then, and that's okay. I don't care. But if you're interested, if you're like, no, I got to amendment come May 2019, I got to graduate. That'd be probably the only way you could do it. The school does not let you take 2 classes at the same time. In other words, in fall, you couldn't take the class these guys took last semester and the one that we're all scheduled to take next semester. They don't let you do that. And it's because of government considerations, the number of hours you're supposed to put in outside of the class, etc. All right, and it's way the heck beyond my control. The other thing I tell you about this, and again, if you're interested, fine. If you're not interested, I can send you more information on it. They also, for that class that they took last semester, there is a test out. And what I mean is, there's 2 tests you have to take. With one of them, it's 130 questions, multiple choice. All multiple choice, A, B, C, D type of thing. If you get, I think it's 75% or above on that, you pass that. Then I have written a test out where you've got to literally create a very small website with 3 or 4 pages on it. If you've never done that before, you probably don't want to do the test out. All right, but if you've got some experience creating websites, even if it's fairly simplistic, then you might want to do it. Colin, the reason he's a little bit off is he took it like you guys did. So last spring was the first time he was in a class. So I told him about it, and he was going to do it, and he's like, 130 multiple choice? I don't think so. So he didn't. He told me he was glad he took the class because he learned a lot. Everybody's different, all right? So that's just something to keep in mind. If I said it too fast or you have questions, see me during the break, send me an email. Anyway, we got time, to think about it. All right, so today, like I said, I'd like to go over Chapter 4 on page 137 on making decisions. If you guys have any questions on this, stop me and ask. Otherwise, I always try to say, you have any questions? But if I say that and no one says anything, I have to take it that it all makes sense. All right? So, understanding the logic planning tools. A lot of times when you're in life, you're driving down a road and all of a sudden the road forks to the left and it forks to the right. And let's assume it's a one-way street. So you can't turn around and go backwards. So you've got to go this way or you've got to go this way. It's kind of like it is with a computer. For instance, let's say that you want to check whether a number is odd or even. The easiest way to do that is to divide the number by 2. If there's a remainder of 1, it's odd. Otherwise, it's even, type of an idea. So that's what we're going to be looking at right now. All right? So learn how to make decisions with an if and if-else, compound expressions with an if. A switch is another way of writing an if. So you're going to see that in just a bit. All right? Use the conditional operator, which is kind of strange looking, but it's pretty neat. Use the not operator. Not is called an inverter. Not single is married. Not married is single. Not true is false. Not false is true. That's the way that that is used. Learn how to avoid common errors when making decisions, and learn about decision-making issues in GUI programs. So we're going to cover all of that stuff. All right? Now, back years and years ago, when I taught at another institution, what they told me there was, you know what? What you have to do is you have to kind of give students a mindset before you do anything. So we literally had, in our class, the first class that students took, they had to learn pseudocode, and they had to learn flowcharting. Pseudocode is kind of a cross between English and programming language. All right. So, for instance, let's just say what I just mentioned to you. You would do something like this. You would say something like, you'd say like input number. If number modulo 2 equals 0, then print number is even. Else print number is odd. And if. Now the reason I'm showing you this is that is pseudocode. There is no programming language that I know of that uses the word input. I'm sure there are some. But the idea is if you write something like this, you should be able to take it to any language. So pseudocode is a cross between English and programming language. That's all it is. And the idea is if you know 10 different languages and somebody gives you this pseudocode, you should be able to say, okay, this is fine. What language do you want me to write it in? And the only thing that'll be different, the logic is the same regardless of the language. The only thing that's different is the syntax, because every language has its own little unique take on syntax. All right? There is also something that's referred to, and I'm going to show you this by going into Google Images. I may have shown you this before. Back in the day, there we go. Mine was green. Do they have the green one? That was the neat one. No, they don't. That's fine. I had to use something that looked like this. And literally, I had to get what was called flowchart paper that was probably about, rather than 8.5 by 11, it was probably double that. So it was probably like 11 by 17, and it had grids on it. And I had to use these symbols to show the progression of a program. That's how I learned to program. All right? I will tell you, very few people use this anymore. There are tools that you can get that will automate it and do it for you. Some people still use it, some purists. But the idea is the difference between this and what I showed you here is this is not at all visual. This is totally visual. This can go right into code. That's harder to go into code. All right? So I don't mean to waste your time, but that's what they're talking about here. And the idea is regardless of how you do it, that you've got a very good idea of what it is you want to do before you do it. All right? And again, some of the people in here may have heard me say this already, but back when I was sitting in your seat, all right, I had a 4-year degree that wasn't getting me anywhere, so I went back and got a 2-year degree. All right? What we had to do was we had to first write we didn't have to write pseudocode. We had to write a flowchart. It had to be literally blessed by the instructor. And once the instructor looked at the flowchart and said, okay, you understand it, then what the instructor did was he gave you we basically had files that had records in them. We didn't get to use our own input information. So it would be like, what I just showed you here, it would be like we would get a file here that would have a bunch of numbers, that kind of thing. And that file would typically have 50 records in it. Like 50 people or whatever. You'd have to do the first 10 of these records by hand. Literally write down what the inputs were, how you were going to process them, and what the outputs were. then once that was blessed, then you got to write the program. Okay? Not only that, our machines, again, this is 20, 30 years ago, our machines were all hooked up to a mainframe. So we had what were called dumb terminals that were hooked up to a mainframe. What the instructors were able to do was they were able to count how many times we ran our program. Once you ran your program more than 5 times, every time you ran it after that, you lost a letter grade. So if it didn't work after 5 times, you couldn't get an A. What that forced us to do was to make sure before we ran that puppy that we really knew it was pretty much going to be correct. All right? So it's a lot different today. I would guess some of you probably run your program 30, 40 times, even if it's just tweaking it before it finally works. I've done that. All right? But that's how stuff changes over time. But the idea is, so far, most everything we've done has been sequential, where one thing follows another. Now we're going to change that. Now we're going to bring in selection. All right? So the author is saying here, I've used things like this before. With sequence, the idea is let's just say that right now we were all going to get into the Rankin van and go down to the St. Louis campus. And even though I've been there before, let's pretend I've never been there before. So I bring my GPS, and it tells me exactly where to go, and I follow each step. We get there. That's sequence. All right? Now, again, we follow each step, but all of a sudden, we're halfway down on 70. All right? And we're going to go to a presentation. It's about 8:15. It starts at 9. And all of a sudden, there's a terrible accident on 70. And we're stuck. But I notice that we can get off, but I don't have any idea where to go then. All right? So the idea is I reroute, right? I do a reroute for the GPS. It tells me another way to go. All right? So when we looked at straight sequence, it was just, come on. That's great. It was just do this, then do this, then do this, then do this, and don't change anything. All right? When you look at what's called selection, it would be like, there's an accident here. Do you want to keep going? Or do you want to reroute and go the other way? So you're able to make decisions. And that's how most computer programs work. All right? For instance, and I don't know if we've added that yet or not, but we will. We'll ask whether or not the person worked overtime. And if they worked overtime, they'll be entitled to overtime pay. And if they did not work overtime, they won't be entitled to overtime pay. So we'll add things like that. All right? So that's the decision structure. One that involves choosing between alternative courses of action based on something. And that's what we're going to get into. The first one we learn about is the if statement. Now, I wish the author wouldn't even show it like this, because what the author shows here, although it's 100% correct, is this statement. First of all, where it says tested expression, it really, rather than tested expression, it really should say here Boolean expression. And a Boolean expression can be what? True or false. So if true, do this. That's all it means. So for instance, if name equal Jeff, right line, hi Jeff. So for all the rest of you that are in here, if you run this, you won't see anything. Does that make sense? Because if it's true, if your name is Jeff, it'll print this. Otherwise, it'll do nothing. That's a straight if statement. Now, if there's more than one statement down here, so if instead of statement, it's statements, you must use curly braces. You must. All right? I recommend always using curly braces, even if it's just one statement, because a lot of times you add stuff. All right? So, that's the simple if, and what we're going to see in just a minute is there's also, we can put an else in here. I realize it's kind of hard to read. But then we'd say else, right line, Hi, stranger. So in other words, if your name is Jeff, so it might ask you up here to input your name. And if you input Jeff, it says, hi, Jeff. If you come in and you put in Jesse, it says, hi, stranger. Does that make sense? That's an if-else. So if it's true, you will do this. Else, if it's false, you will do the other one. And the idea is this one has to execute or that one has to execute. Only one of them can, but one of them must. And if you understand that, there's nothing more to this. All right? That's exactly, the way that the computer works. Because remember, the computer understands two things. Really, that's all the computer understands is two things, zeros and ones. Zeros typically mean false. 1 typically means true. All right? So there's an example. Now, if you look at this, because it's really important that you see this, if number is less than 5, if you want to write both A and B, you need the curly braces. Did you hear that? Right now, if number is less than 5, you write A. But you always write B. Always. Because it's not within what's called the if code block. So if you wanted those both to happen, you'd have to put in curly braces and then put both statements in there. All right? So some of the examples, he just keeps beating on the same thing in here. So there's an example. So now if it's true, you do both of those because it's inside of curly braces. Now, what if I said this? I can actually have what's called a complex condition. Okay? I don't know if you agree with this or not, but sometimes with people, some people, I actually heard people debate over this. Is 0 an odd number or is it an even number? And I'm to the point where I don't care, but I'd say it's neither. Does that make sense? I'd say it's not odd, it's not even. And I've heard people say it's even because the number that comes after it is odd. And the number before it, -1, is odd. And so if you've got two odd numbers, the one between must be even. Okay? And I was always told that any number that's even must be divisible by 2. Technically, you can't divide 0 by 2. It doesn't make any sense. All right? But the point is, if I wanted to do this, let's say that I said if the number, okay, what if we started by this? I'm going to do this. If I said if the number equals 0, then print number is neither odd nor even. Okay? Now look what I've introduced, an else if. Now, because there's 3 possibilities. The number's 0, the number's even, the number's false. That make sense? All right? So this pretty much is the way that you typically are going to code this. We'll use lowercase letters, but I'm just using the uppercase so you can see. So it stands out, you can see what's happening. All right? You can also have an if within an if. So, you guys heard me do this example last semester, but I'm going to do it again anyway. All right? So, I'm going to come in there and I'm going to do this. I'm going to say right now, get rid of that, make this a little bigger. All right, this isn't true, but I'm having a party. All right? To come to the party, you must number 1, be 21 years of age or older. Why? Because we'll have alcohol. 2, be a student in the Rankin Technical College AWD program. Now, does that make sense? You want to come to the party, both of these have to be true. All right? And it's going to be for anybody, so people in the St. Louis campus also. So I want to say something like this. If age is greater than or equal to 21 and, let's call it student status equals RTC AWD. I'm just making that up. Then you can go to the party. All right? Else, you cannot go to the party. Does that make sense? What I'm saying, does it make sense? All right. And it's good news and bad news. Okay, the good news is some people are coming to the party. The bad news is, all right, the bad news is I bought enough food for 250 people and right now 5 are coming. So I've got way too much food. So I say that, you know what, you can come to the party. You must either be 21 years of age or older or be a student in there. So I want to change that from this to this. Now, if this is true, or this is true, or they're both true, you can come to the party. Otherwise, you can't go to the party. All right? So what I'm showing you is literally what's called and or logic. With an and, when this was the word and, both of those must be true. When it's the word or, either or both are true. The whole thing is true. All right? So, next they talk in here about nested ifs. Okay? So let's say that I want to do this example that I was showing you before. This thing. All right? And I want to tell if it's odd or if it's even. But let's say I only want to do this if the number is 0 or above. Are you with me? I only want to do this if the number is positive. All right? And we'll say 0 in this case is positive. So input number. So I'm going to say here, if number greater than or equal to 0, then I'm going to grab every bit of this, and I don't know if this will work or not. It didn't. So I got to do it because this is a stupid editor that I used. Now, if you notice, I have an if statement within an if statement. So the only way that I get into this code right here is if the number is greater than or equal to 0. Does that make sense? That's how what a nested if statement works. All right? Now, could I have rewritten this another way? Of course I could have. I could have said, if the number is greater than or equal to 0 and the number is, I guess I could have done this first. If the number is equal to that, do this. Otherwise, if the number is greater than or equal to 0 and it's divisible by 2, do this. Otherwise, do this. What I'm trying to get to is when you've got a nested if, it's an if within an if. You can nest any kind of computer statements. We're going to learn about loops tomorrow. You can nest one loop within another loop. You can nest an if within a loop within an if. All right, you can nest anything. Nesting involves putting something inside of something else, period. So if you look here, there's an example. You see there's an if within an if. Why this author does not use curly braces there so you can really see things, I don't know. I wish she did. She doesn't. So, I already mentioned this, but you've seen it now, the if and the else. If I have just this, if I don't have an if, That means if that expression is true, you do that statement. Otherwise, you do nothing. Does that make sense to everybody? All right. So that's like, again, that's like saying that the example I put up there before, if name equal Jeff, then print hello Jeff. And if it's not Jeff, you don't do anything. Then we changed it to add else, print hello stranger. So again, the idea when you do this is either that line of code right there or that line of code right there must fire. So when you've got an if-else, either the one or more lines under the if must execute, or the one or more lines under the else must execute, but they cannot both execute. All right, that's like saying, you're doing a payroll program, and you say if hours worked are less than or equal to 40. Well, then you can't get overtime. Okay? So else would mean they're not less than or equal to 40, meaning they're greater than 40, then you can get overtime. All right, so that's what we're going to build towards in just a minute. Now, one thing about this, people sometimes think, well, you can line stuff up, so this else that's right here must go with that if because they're both lined up with one another. All right? And actually, if you had a language like Python that does do and lines things up based on tabbing, that might be true. All right? But not necessarily here. Okay? In fact, if I want to make sure this works exactly the way that I want it to, so let me copy. Oops, I thought I could copy it from there. Yeah. Let's see if it took that. All right. If I want to make sure that it works the way I want it to, I'm always going to use curly braces. And again, this may look like overkill. I don't care. Yeah, it's a little bit more to type. That leaves no doubt to the computer. So the only way that you do this is if that's true. If that's not what I wanted, okay, then I can write it another way. But the only way that I get into this is if that is true. That should make sense to you. All right. So again, maybe I have too many curly braces there. Some people say, yeah, you put in so many, you make it hard to understand. Sorry, I think it's easier to understand. All right. Here they've got a program in here. If you're struggling in here at all, this book is filled with programs the authors created. All right. Such as, well, here's one where they tell you to enter 3 integers. All right. Then they use an if statement to see which is greater or which is less, the smallest integer. There's other ways of doing it, but they're showing a very simple way using if statements. So you see that? No two numbers are equal, which is true. Here the first and the last number are equal. Here the second and the third, or the last two, are equal. All right? And the thing is, you might look at that and go, well, yeah, it makes sense. I get it, etc. But the thing is, you have to realize when you are dealing with a computer, you are dealing literally with a piece of hardware that's got the intellect of an 18-month-old child. That's not a joke. It's the way it is. Most computers understand a couple hundred words. All right? But the difference is if I'm trying to work with an 18-month-old child and they're not doing what I want them to do, I can scream at them. All right? They probably still won't do it, but I can make them cry. But the computer, it's like when I watch people do that, doesn't work. I'm going to hit the keyboard harder. Yeah, that'll definitely make it work. All right? So we looked before at that and statement in here. And, well, maybe it was the other one. This. All right? Just so you know, in this language, you don't use the words and or. Did you hear me? You don't use the words and or. Instead, for an and, you use 2 ampersands. That means and. If it's an or, this is the key that's right up above your enter key. Hold down on shift and tap that twice. That's called a pipe sign. All right? Just so you're aware of that. So you're going to see that in here right now. There's the and there's the or. Now they go through these things here called truth tables. Do you have to know what a truth table is? No. All right? You can take a look at it on your own. I don't want to throw too much stuff at you. All right? Now you can't do stuff like this. Virtually no language, computer language, is smart enough if sales amount greater than 1,000 and less than 5,000. What you have to say is if sale amount greater than 1,000 and sale amount less than 5,000. You've got to put them both in there like they show down here. All right? Again, that's just the way it works in most programming languages. It's not like that's the way it works. Do you like it? Because it's just the way it is. All right? So that's what we have to do. Now, also, it uses something called short circuit evaluation. Most people, when they hear this the first time, they get very confused. So let's look at a real-life example that hopefully will help you understand it. I'm going to remove all this stuff. All right? I'm going to create 3 variables. They have no meaning whatsoever. Int x equals 27. Int y equals 10. And int z equals 31. Again, like I said, these variables have literally no meaning. All right? I'm asking you this question here. I'm going to say here if, and I'm going to put a lot of parentheses in here. X less than 25 or y is greater than 6. Okay? I don't care what I'm doing. I'm going to do something if that's the case. Okay? In fact, let's use and first. With an and, both of these have to be true. So, is x less than 25? Is it? No. So what happens with this language, like most languages, is it uses something called short circuit evaluation. What that means is this. I have to check this. I have to check this. I have to check both of them. But the system says, you know what, it's an and. They both have to be true. Since the first one is false, why the hell do I check the second one? It makes no sense to check the second one. Do you understand what I'm saying? You don't have to. All right? Now, what if I used an or here? Now it has to still check them both. Because this is false, but that still might be true. If I use an or and I do this, all right, now the first one is true. With an or, if they're both true, or if either one is true, the whole thing is true. So with an or, since this is true, we don't check that one. That's again referred to as short circuit evaluation. To my knowledge, that'll be on your written test. All right, asking you what that is or what it's called. These things they're showing here, they're called truth tables. All right. Again, do you need to know them? You can take a look at them. All right. Now notice here, this is the top of page 157. All right. And on the top of the page here, the author is showing you 2 different ways of doing the same thing. It's comparing using an or with using a nested if. So this says if the age is less than 0 or the age is greater than 120, okay, you write age is not valid. That's done in one line. Here it's done using an if within an if. So if the age is less than 0, you write this. Else, if the age is greater than that, you do this. In this case, I would say the first one is better because it results in less code. But if the second one is easier for you to understand, then that's the way you should be writing it for right now. All right? I've said this before. When you're a first-year student, you should always be programming for understandability. All right? Now, there's a term in here. We talked about Boolean and, all right, which is this, and Boolean or, which is this. We've already talked about those. Oops. They also, I think this is on the test, what's called a side effect. A side effect simply is an unintended consequence. All right? Now, most people know this. Some of you in here probably smoke. But as an example, if you smoke, the chances increase that you get lung cancer. That's not an unintended consequence. That basically, you know that ahead of time. But you can say, geez, I never knew that. Then technically it is an unintended consequence. All right? Let's assume that as time goes on, because I've been trying to do this for years, I finally learned how to play the guitar. And after I learned the guitar, I'm realizing, wow, I get these patterns. That's a lot like this program I'm writing. So by going and learning the guitar, it helps me in programs I'm writing that use pattern recognition. That is an unintended consequence. I did something, but there was a consequence over and above. Some side effects you want to have happen. Some side effects you don't want to have happen. All right? And if you don't get it, we're going to be talking about that more as we go on in here. All right? Okay. You can combine things together, and that's what I kind of showed you, but not only can you can have as many of these as you want. So that example that I showed you before, where we had the and, I guess it was the other one, where we had the and the or, you could have as many things in here as you want. If this, or this, and this, or this, or this, and this, etc. You can have as many as you want to or need to have. To me, the more things that you put in here, I would never write it like this. I would put a parenthesis here and here, I would put a parenthesis here and here, and I would put a parenthesis here and here. All right? Since it's an or, I can tell, but first of all, this uses is, so these are Boolean. If that's true, or that's true, or that's true. So in other words, if it's a weekend, Saturday or Sunday, if it's some kind of a holiday, or if I'm sick, I write no work today. Since it's an or, because any one of them could be true. If I put and there, it would have to be a weekend that's a holiday that I'm sick. So if I put an and, all of them would have to be true. But by using an or like we are, any one of them can be true. All right? We'll go for about 5 more minutes and we'll take a break. And they actually had a program here. I just went by it, but it's not too bad. Except it won't let me go backwards anymore. Fantastic. It's a movie thing. All right. So basically what they're saying in here is when the age is, all right, and we got age set to what? Age and rating. So it'll say when the age is 10 and the rating is R, the discount applies. Well, technically when the age is 10 and the rating is R, what should happen is you shouldn't be able to go to the frickin' movie. All right? I don't know what happened over time, too. When I was your age, we had X-rated movies. You know, you wanted to be of illegal age just because you had no idea what they were about, but you wanted to go. Now, you know, I'll go to an R-rated movie. I remember going to a movie, I can't remember the name of it, but it was a war movie, but it was R because there was graphic violence in it. There was a lady in there, she had like 3 or 4 little kids. And I don't mean babies. You know, the youngest was maybe 7 or 8, and I'm thinking, that really isn't right. But I guess since she's an adult, they let her go. And they let the kids come in. I'm sure if I'd have said anything, she would have told me what I could do. So, didn't really need that. All right, this is a good place to stop. So we'll pick it up on page 163 after the break, talking about what's referred to as the switch statement. So we'll go over that. We literally have about 10 or 15 more pages left in the chapter. After we do this, we're going to go back and we're going to go back to our payroll program and we're going to add some if statements to it. All right? So we'll do that all after the break. It's 8:57. Let's come back, please, around 9:10.